Okay, we're ready for the second part of this after our second test lecture example. This one is going to look at the time value of money. It doesn't necessarily fit into any of our parent accounts when we're looking at assets or liabilities, but I think it goes well here in the liability section anyway. The time value of money is going to show us how much is, and it kind of, you can just read off what I have here. If I have $100, what's that worth today? Or I could look at it the opposite way. If I have $75 today, how much is that $75 worth if I wait to get it until sometime in the future? That's what's considered the time value of money, and this works great when you're dealing with retirement type issues or annuities, and we're going to look at those examples here as we go through. Now, when I put a question mark here, when I say, well, it tells us what something in the future, say $100, you were to give me, you gave me the option, I'll give you $100 in 1 year, or I'll give you 75 today. Well, that all depends on what the current interest rate is for whatever you're working with. The interest rate could be anything from if you're just putting it into a bank and earning interest, or it could be putting it into a stock account and earning interest over the year. It could be as simple as if you're a business, if you get $75, well, that's more money for you to go out and buy more inventory. Of course, then you mark it up. And then with that $75, how much would you walk away with at the end of the year, assuming you sold all that inventory? Would you have $100? Well, that's a markup. That would be called a rate of return. It's just like an interest rate. So there are two types of time value of money examples that we're going to look at. The first one is I'm just going to get paid, or I'm going to pay money at one time and that's it. Those are our lump sum payments. And you'll see those when we look at charts that they're called of a dollar. Of a dollar simply means lump sum type payments. Then the other option will be our annuity payments. And annuity payments are equal payments over time that I'll give you a little bit more specifics in a few minutes when we get to that section. So we got lump sum payments and then payments usually like on a monthly or yearly cycle. First, we're going to look at the lump sum payments. And a question would be, if I have $1,000 right now today and invest it into, say, a stock account, how much would I have in 10 years if that money just kept building and I did nothing with it and I just kept earning interest? Well, one of the clues that we're going to need to start asking ourselves is, what do you know? And then what are you trying to find? I know what I have right now today. I have $1,000. I'm looking to find what I need in the future. So when we get to the charts, this is going to be my key word. I'm going to need to look at a future type chart because that's what I want to know. I don't need to look at the present type chart because I already know what the present is. I've got $1,000. It's right there in my hand. What I don't know is how much is that $1,000 going to increase to in the future over 10 years. And then the last thing I would have to always give you is how much of a return can I get, whether I'm in a business or investing in the stock market. And I said a 10% rate. Well, if I was just to go out, I said 10 years here, but I'm just going to go out 3 years. Let's just change that to 3 just for my example. We could keep going here if we wanted to 10 years, but just for the 3 years to do so we can have a stopping point. You can do this the long way, and it's fine. If you're only doing it for 3 years, it's not that bad. What I want to do, doing this the long way, if I have $1,000 today, I can easily calculate what that's going to be worth in 3 years, going at it year by year. I can say, okay, I've got $1,000, and then going back to what we did just in the last video, I equals PRT. If I do 1,000 as my principal, that's what's there in the bank or in the stock, I get a return of 10%, so 1,000 times 10%, and my time, well, that worked out real nice because I'm only talking about 1 year, so my time is just 1. If you multiply that out, I earned $100 this year in interest. So at the end of the year, sitting there in my account, I have $1,100. Come down to year 2. Well, instead of having $1,000 to earn interest, I now have interest on top of that. So in a sense, I have interest earning interest. Therefore, my principal now becomes $1,100 times my rate at 10%. And now I've done it over another full year, all of year 2. It doesn't seem like much, but over time this will begin to add up. I have another $10 of extra interest. Now notice this is a whole year's worth in addition to this. I already had this 100. Now I've got another 100 plus the extra $10, so 110. So the amount that I have in the bank, my old amount plus another 110, I'm at $1,210. Keep doing that now for year 3. Add in my new principal. So my new principal is $1,210. Get my interest. I have now in the bank $1,331. Okay, so that's the quick way, but we want to go a little bit faster way if possible, especially if we're doing it over a 10-year period, maybe even 20-year period. What we have to do to use our charts, and the chart that we're going to use here would be the future value, because remember, I'm looking at a future amount that's unknown, so that's automatically sends me to the future ones, and there are 2 future ones. But then the one that I want is the lump sum, is I'm only making a $1,000 payment one time. So I want the of a dollar chart, which is the lump sum chart. And then you'll see going up and down are what the chart lists as periods. In math or in any type of number type class that you may have, periods usually has a variable of n. And n is simply the number of compounds. The interest is compounding over its life. And it could be compounds are the same as payments as well. So if you have payments, you can substitute those 2 words and put number of payments over life. But when I put number of interest compounds, what I mean is, with my example up here, it was very easy. My interest just compounded once a year. I calculated interest one time each year. And so my N would have only been 3. My 1 time interest, and then my second interest, and then my third interest. But if I would have done it where every 6 months I calculated interest, well, at that point I would have said my N is 6 because I'm calculating interest 6 times. So the easy way to do it is simply say that I've got 3, take your number of years, you take your number of years and then multiply it by how many compounds per year. That's how we're going to get N. I is almost the same as you'll see. Interest is, well, what's our yearly interest per compounds in a year? So in this example, I only had 1 compound a year, so my interest rate was very easy. It was just 10%. But if you have something like I did in the previous one where I said, oh, it's doing it every 6 months, your interest actually, let's get this on here, your interest is actually your yearly rate, so in this case 10%, but now instead of times your compounds per year, it's divided by your compounds per year. So if I had a 10% interest, my yearly rate, I divide that by 2 compounds for every year. That's really telling me it's 5% per compound, which should make sense. If it's 10% for the entire year, it's 5% over 6 months. So I give us a little example here to make sure we've got this. If I have interest, I give us an example where I say interest is compounded quarterly, or otherwise saying it compounds 4 times a year, and I'm doing this for a 5-year stint. I have a stated annual rate of 10%, and then before you can do any of the charts, you have to figure out, well, what N and I am I going to use? So remember, for the N, you take your number of years that you're having this, whatever this scenario is, so it'd be 5, times the number of compounds a year. We're compounding it 4 times a year. So I'm going to have 20 compounds when I'm looking at my chart. I'm going to go down to that N period of 20. And then I'm going to go over to the interest side and look up, okay, I've got a 10% yearly rate, but I want to divide it by the number of compounds in a year, which is 4 again. So instead of timesing it, we divide it. So what I'm going to look up on my charts, and our charts don't have, they only go in whole numbers, so I wouldn't be able to give us this example. But it would be, we would look up 2.5%. Bold this because this is important, that things that we're going to need to remember. I'll bold it later. I got another example there if you wanted to look at it. You can pause here. I'm not going to go through it, but if you wanted to pause, because this one's dealing with payments, so we have 12 payments in a year. I guess maybe we can go through it. 2 years times 12 payments in a year. So I have 24 payments altogether. What is the interest per payment then? So I have a 12% annual rate divided by 12 payments in a year. So over every month, it would be 1%. So let's look at this little example that I've made up for us to use our charts. If I have $6,000 and it's going to be paid off, or it's going to be paid in 3 years, I want to know what's that $6,000 worth. Well, and then I got to determine, do I want to know what it's worth now or later? So I said here, what is $6,000 to be paid in 3 years worth today? So instead of maybe me paying somebody $6,000 in 3 years, because that's when the bill comes due, how much could I pay them right now with time value of money, and neither party would be upset? I could pay them a lower amount because they're getting their money faster, but even though I'm paying them now, I get to pay a lower amount. And we're going to assume an 8% rate of return that's compounding semi-annually. So a few clues. One clue is we're dealing with a lump sum. We haven't even looked at payments yet. So we're dealing with a one-time $6,000 payment, one-time lump sum. My second clue is I want to know what it's worth right now, today. Therefore, I want to use one of the present value charts. And a present value looking at a lump sum. So I want to use the present value of a dollar chart. The next thing that I have to get is my N and I numbers at that point. My N is, well, it's going to be paid off in 3 years. That's how long it is. But then I do have semi-annual compounds, so those happen twice a year. So in total, I'm going to have 6 interest calculations. So that's what my N is. That's what I'm going to use on my chart. And then I'm going to go 8% annual interest, but I'm calculating interest twice a year, so I'm only going to use 4% as my semi-annual interest rate. If I look up on the present value of a dollar table, N is 6, I is 4, you should get 0.790. Multiply that by our known figure, the lump sum. Neither party would be hurt if instead of paying $6,000 in 3 years, $47.40 was paid right now. That's how the time value of money works. So a recap, this may help you on a test or a quiz or homework assignment on knowing what chart to use. For the future value of a dollar, you've got to have a lump sum. And you know what you have now, but you don't know what you're going to have in the future. That's why you need the future value, what you don't know. Just the opposite for present value. You still are dealing with lump sums, but I know what I'm going to have in the future, say my $6,000 payment. How much is that worth right now? All right, so that was looking at lump sums. Now we're going to do just the opposite. We're going to do payments. When you have payments, a lot of times these are called annuities, but for something to be called annuity, it does have to meet 3 criteria. A, your payments always have to be the same, kind of like a car payment. Whereas some payments, like student loan payments, you can kind of choose what you use, but some of them, like the one I have, it's a graduated plan. It wouldn't be considered an annuity because about every year, every 2 years, the amount goes up because they assume maybe you're making more money than you were 2 years ago, two years before that. So it started out pretty low, and now it has continually risen. So the payments don't change. You have the same payment intervals, and what I mean by that is you're paying it at the same time all the time. You're not just paying it on March 15th and then you make another payment at random July 1st and then another payment at random July 15th. It's got to be the same time, first of the month or first of the quarter or the end of the month or the end of every year. Whatever it is, it's got to be the same. And then the other part that's got to be the same is it's got to be the beginning or the end. Can't have it either way or just whenever during the month. Say it's got to be, if it's at the beginning, it's got to be the beginning of every month. It can't be the beginning of some months and the end of some months. It doesn't work like that. Now, your charts are set up, it'll say at the top, future value of $1 or future value of an ordinary annuity when we're looking at the payments. An ordinary annuity are when the payments are made at the last day, at the end. And our charts are set up exactly for that. However, if payments are required at the beginning of the month or the beginning of the year, whatever it is, these type of annuities are called annuity due. And if they're an annuity due, you have to tweak your chart just a little bit. So we still do our same in and same I calculation. But if it is an annuity due, so I want to know, let's say I have a retirement account and I put away money every month, $100 every month for the next 30 years. Well, first thing I had to find is how many payments am I putting away? And that would be quite hard to, we'd have to get out a calculator maybe to do that. If I made payments for the next 30 years, well, that would be 12 payments in a year times 30 years. My in would be 360 payments that I'm putting into a retirement account. If we're dealing with an annuity due, where now instead of putting it in at the end of every month, I'm putting it in at the beginning of every month, I would have to add 1 to that in value. So instead of using 360 on the charts, which of course our charts don't go anywhere near that, I would have to use 361 if it was an annuity due. It's simply just tweaking the chart just a little. The I value, whatever I come up for the interest rate, no change. We don't do anything to that. But then when I get to the number that the chart has, let's say the chart had a number of 102. Well, I would have to subtract 1 from that. So what the number I would actually use when I'm doing the multiplication would be 101. Because I subtracted 1.00 from the number on the chart. This is something that you will want to put on your charts. Have it at the bottom in that open space. What to do if you have an annuity due, so a type of payment that is not end of the month, because your charts are set up for the end of the month. But what happens? How can you still use those same charts even though it's an annuity due? Okay, so let's look at an example. We have a life insurance set up, and instead of doing it more commonly, which would be per month, since our charts don't go very high with in values, I'm going to just round it up and say we do it on a yearly basis instead of monthly basis, which isn't necessarily how it really works, but we have to go with what we have on our charts. If we have 14,000 coming in per year, so roughly that's about 1,000 a month, a little bit more, but $1,400 per year coming in for the next 10 years. And we're going to assume that I can get a 6% return on that, however I want to get that return. That's what the return rate has been given. Well, there's nothing listed in here about multiple payments in a year, and there's nothing in here about semi-annual or quarterly compounding. So my N is simply just the number of years. I'm not doing anything special during the year. And then my interest, since there was nothing special with my N, there's nothing special with the interest. It's just 6%. So I want to know, I know what I'm going to get on a year-to-year basis. I want to know what is the total return value of the entire $14,000 at the end of that 10th year. How much will I have earned if I put it all away into a interest-bearing account that I get 6%? And then we can go to our charts. Remember, I know that it's A, a lump sum, my clues. My clues are A, it's a lump sum. B, I'm dealing with multiple payments. So I need to go to the future value of the annuity. Future value of the annuity, if I go to the chart, for N is 10, I is 6, I get 13.181 on the chart. Take my known amount, the payment of 14,000 times that number on the chart. 14,000 is actually worth 184,534 in 10 years at 6% interest. If we simply change the interest to 7 or 8%, this number will reflect that in quite a big way. Changing the interest 1% over time makes a big difference. So the second question here I asked then is, how does any of this change if the only thing that Matt differed is, instead of getting paid at the end of the year, I'm now paid at the beginning of the year? Well, now in that case, we have an annuity due. So we're going to add 1 to our N. I, remember, stays the same. When I look this up on the chart, you get 14.972. And then at that point, I want to subtract 1. So actually getting me down to 13.972. Take my 14,000 times 13.972. As you can see, by getting money at the beginning of the cycle instead of the end, does give me more money because I have more money up front earning interest, therefore more money overall. The last item that we're going to look at is the present value of the annuity. What this will allow me to do is, if I ever want to know if I'm going to, instead of me getting paid, and this is a really good lottery type example, where if somebody won the lottery, they would want to go through this with their accountant, is to say, if I win the lottery and they say they're going to pay me $1 million every year for the next 20 years, so that's 20 million, how much could I get right now today instead of $1 million every year for 20 years? That would be considered the present value of an annuity. I'm getting A, payments, and I want to know what those $20 million $1 payments will be over 20 years if I got paid right now. And then if it's not at the end of the month or end of the year payments, they happen to be at the beginning of the month or beginning of the year payments, we have a very similar little tweak to our charts. Our charts are currently set up as an ordinary annuity, meaning end of the month or end of the year payment. If it's a beginning, we do just the opposite of what we did before. Instead of adding 1 to N, we now subtract 1 to N. Do nothing to I. And then instead of subtracting 1 from the chart, we add 1 from the chart. So you will want to note this on your charts. What happens if you have an annuity due? So here's my example. Instead of receiving $5,000 at the end, that's key, at the end of the year for the next 8 years, so a total of $40,000, How much could I receive right now today, assuming a 7% rate of return? Okay, so the first thing, I know my clues are I'm dealing with payments because 5,000 for the next 8 years, 5,000 at a time. And I'm dealing with, I need the present value tables because I want to know what's that worth today, right now. What are those payments worth right now today? So present value of an annuity. The final key thing is, do I need to do the tweak? And the answer is no, because it's end of the year payments. My charts are set up as an ordinary annuity, end of the year. So my next thing is N and I. Nothing special going on during the years. There is no semi or quarterly compounding, no monthly payments. They're yearly payments. So my N is 8, just the 8 years. That's when payments are made every year. Interest then, therefore, is no change to what it's given to us, 7%. The final, our calculation then, take what we know, $5,000 payment, times what the chart tells me at that particular mark. So instead of receiving $40,000 over the next 8 years, I could receive $29,855 and neither party would be hurt. Everybody would be happy. Now, how to look at that from how does it change if we have a beginning of the year instead of end of the year payment? Well, we do have to do the little tweak at that point. So instead of N as 8, we're going to subtract 1, so we're going to use 7. Same I. When you look that up on the chart, it's 5.389. Now we're going to add 1 back to the chart figure. So I'm going to take 5,000 times 6.389. And as always, whenever you get paid ahead of time, that number is going to be higher than if it was end of the month. So comparing the 29 to the 31,000. All right, that will do it for this week's. We did payroll, interest, and now time value of money.